All right, so we're just continuing that same idea from last time. We're just going to continue on that same path. All right, so the three types of systems of a solution are one solution, infinite solutions, no solutions. Real quick, just review. Here, if we get one solution, we will end up with x equals a number and y equals a number. So we'll have a nice pretty pair. Infinite solutions means we'll end up with something like 0 equals 0. No solutions means we'll end up with something like 0 equals -2. Okay? That's what it will look like when we find this. So right here, let's go ahead and try this one. Notice everything lines up. X's line up with X's, Y's line up with Y's, equals, and numbers line up with numbers. Beautiful. The only problem is they don't match on any of the numbers. So if I want them to match, let's say I want to get rid of my X's. I'm going to take the number in front of the X on the bottom, and I'm going to multiply that through on the number on the one on the top. So this becomes 2x plus 4y equals 10. So I multiplied it to every single piece in there. Then I'm going to take the number next to the x on the top, lucky for us it's 1, and I'm going to multiply it to everything on the bottom. So 1 times -2 becomes -2x, 1 times 3y becomes 3y, and 1 times 4 is just 4. So from here you'll notice we can already just add them. So I've got 2x minus 2x, that's 0. 4y plus 3y, well that's 7y. And 10 plus 4 is 14. From here I would divide both sides by 7, and I end up with y equals 2. This is where I take my favorite equation, which for me today is that top one. So I've got x plus 2y equals 5. I'm going to replace my y with 2. So this becomes x plus 2 times 2 equals 5. Well, 2 times 2 is 4, so x plus 4 equals 5. Subtract 4 from both sides, and we get x equals 1. So my solution to the system is 1, 2. All right? Let's take a look at this next one. Again, we see that the numbers don't match. We need them to match. Again, I'm just going to get rid of x just for funsies. So I'm going to multiply this top equation through by a 1, because the number in front of my x, I know there's a negative, but the number right in front of my x is a 1. So I'm going to do 1 times 2 is 2x, 1 times y is a positive y, and 1 times 3 is just 3. On the bottom, I have to be a little more careful, and I'm going to multiply through by this 2 that's next to that x up top. So I do 2 times -1, and I get -2x. Oh look, they're going to go away. 2 times 3y is 6y, and 2 times -12 is -24. So now I can add them together. So I've got 2x minus 2x is 0, 6y plus y is 7y, and 3 plus -24 is -21. From here I can divide both sides by 7, and I end up with y equals -3. Now I get to pick an equation that I like. I like the top one, so it's 2x plus y equals 3. I'm going to plug in a -3 everywhere I see a y. So this is 2x, and then this will just be plus a -3, which is just -3, equals 3. From here we would add 3 to both sides. And I get 2x equals 6. Then we would divide both sides by 2, and we get x equals 3. So my solution here would be 3, -3. All right, this one. Does everything line up correctly? No. No, it does not. So we need to make everything line up. So I want my x's and y's on the left, so I'm going to subtract 3y on this equation. And I'm going to move my x's and y's on the left on this one. So this one's going to become -9y minus 21x equals 6. And then I'm going to put the -3y, because we had to subtract it to move it. And we've got minus 7x equals 2. Now, if you notice, currently, got lots of weird things going on. They don't match. So I'm going to multiply the bottom equation through by a 9. And I'm going to multiply the top equation through by a 3. So 3 times -9, I'm just going to rewrite these down a little bit. So 3 times negative 9 is negative 27y. Then 3 times negative 21 is negative 63x. Then 3 times 6 is 18. Then the bottom becomes 9 times negative 3 is negative 27y. Then 9 times negative 7 is negative 63x. And then 9 times 2 is 18. And you might notice that we've got a negative 27 and a positive 27. So I'm going to go through and change the signs on the bottom one. And now we can add them together. So we've got negative 27y plus 27y, that's 0. Negative 63x plus 63x, well, that's another 0. And I've got 18 plus negative 18, that's another 0. So I end up with 0 equals 0. This is infinitely many solutions. Infinitely many. Okay? All right, let's take a look at this one. Again, I have to rearrange, and I want my x's and y's on that side, so I'm going to add 3y to both sides on this top equation. So this top equation is negative 2x plus 3y equals 1. And the bottom equation, I'm just leaving the same. We've got 6x plus 2y equals 30. Right now, they don't match. So I'm going to multiply the top equation. I'm going to get rid of y's this time. So I'm going to multiply the top equation through by 2. And I'm going to multiply the bottom equation through by 3. So 2 times negative 2 is negative 4x. 2 times 3 is a positive 6y. And 2 times 1 is 2. Then on the bottom, I've got 3 times 6 is 18x. 3 times 2 is a positive 6y, and 3 times 30 is 90. Now, if you notice, I need to change my sign so that the positive 6, the 6's goes away. So I'm going to change this to a positive 4, negative 6, negative 2. So I've got 18 plus 4 now, and that's 22x. Negative 6y plus 6y, that's nothing. And then negative 2 plus 90 is 88. From here, I would divide both sides by 22, and I end up with x equals 4. That's quite a lovely number. So now I'm just going to plug this into whichever equation I feel like plugging it into. I'm going to pick the original first one, negative 2x equals negative 3y plus 1, and I'm going to take my 4 and plug it in for my x. So here it's negative 2 times 4 equals negative 3y plus 1. So I have negative 8 equals negative 3y plus 1. So I subtract 1 from both sides, and I get negative 9 equals negative 3y. And I divide both sides by a negative 3, and I end up with y equals 3. Thus making my solution 4, 3. All right, I need you guys to go ahead and give this one a shot, then this one, and this one, and then we'll come back together on this. You're going to be able to use any method you want to solve, okay?